Hello everyone, a warm welcome to TGIF, your weekly source to get the latest and greatest that's happening in the world of tech. We are all building generative AI apps. We have had a ton of announcements that come in our way during a recent conference Ignite. And today we're going to talk about a special topic which will help you to build enterprise grade generative AI apps. And we have another new offering for you. So let's see what is this topic about. With me, I have Satish from the Global Black Belt team who is joining in for a short conversation on this topic. Hi Satish.
Hello, Divya. Thank you for inviting me here. It's great to be here again.
Thank you for being here, Satish. So, what are we talking about today, Satish? What is the topic that you want us to go through?
Sure. So today we are going to talk about Azure Managed Redis offering, which was announced as a preview during Ignite 2024.
Wow, Azure Managed Redis. Now, we've had Redis for quite some time on our Azure platform. So, how different is this offering, Satish?
Yeah, that's a great question, Divya. So Azure Redis or the managed Redis has been available on Azure for nearly 10 years now, and it's been used for various use cases as an in-memory data store like a cache or a database or even a message broker. Now, Azure Managed Redis brings all the latest innovations from enterprise Redis as a managed service on Azure. So it provides automated zone redundancy, it provides geo replication, it provides fine lines availability, it provides advanced features like working with JSON document structure, working with time series document structure, enabling Redis search on vector store, etc. in practically all SKUs and all tiers.
Wow. So you brought in the concept of vector store, right? Redis being a vector store. That's very wonderful. So, I mean, does it also lead us into thinking that this offering can also be used for generative AI applications?
Yes, absolutely. So when we build generative AI applications, uh, we have to work with vectors, right? So if you think about the RAG pattern or retrieval augmented generation, we are essentially talking about storing enterprise knowledge or enterprise information in a vector store. Now, because of Redis enterprise support for storing vector data, we can essentially use Redis as a vector store that can be used in implementing the RAG pattern. Additionally, we can also bring in the concept of semantic caching. So essentially, Redis has been used widely as an enterprise cache. Now, the concept of semantic caching essentially means that we will be able to do a vector search. So it's not a keyword search. So the match may not be at a keyword level, but rather it will be based on the vector search. So we'll be able to implement patterns like the KNN or the nearest neighbor based on the vector distance. So this opens up exciting possibilities to make your GenAI apps perform more efficiently, improve the latency, etc.
Wonderful. So we have yet another offering when it comes to building apps using generative AI. So what are other scenarios where I could put this service offering to use, Satish?
Yeah, again, great question. So the core use cases for using Redis as a cache or as a in-memory data store or as a message broker still remain. With Azure Managed Redis, what we have, as I stated, are enterprise-grade capabilities that are available in all SKUs and all tiers. So if you have high performance requirements and you want to cache information, then Azure Managed Redis would be a great offering to work with. If you have a requirement to store your vector information, either as a vector store or for semantic caching, then again, AMR is going to be a great offering. If you have a requirement around storing session information, then again, AMR can be a great offering. So
Got it. Got it. Yeah. So yeah. So can we have a demo of this one? I think it's a great offering. I know you've listed a lot of scenarios, but even if you could show us one scenario, I think that would be great.
absolutely, I'll be keen to do that. So let me quickly share my screen, Visual Studio Code IDE. Now, what I have done previously is I have created um, a Redis, a managed Redis in Azure, and I'm going to create a semantic cache index in my existing Redis, managed Redis in Azure.
Okay.
Right? So let me go ahead and do that. So I'm naming this LLM cache demo TGIF. That's the name of my semantic cache index. Now you also see a distance threshold, right? So when we do vector search, this distance threshold is going to help us, find the nearest neighbor, right? So when we do a cosine similarity search, this distance threshold is going to determine the result set that is going to be returned, right? So let me go ahead and create this index in my Azure Managed Redis. Right, that's got created now. Now, let's ask a simple question, right? So I'm going to ask what's the capital of India, and then I'm going to see if my cache has the response for that, right? So right now our cache is empty. So yeah, we got a response saying that the cache is empty. Now let's go on. So let's actually populate the cache. So I'm going to again ask the same question, and then I'm going to store the response as Delhi, and that's been populated. Now, what's happening behind the scenes? So here, what the library that I'm using is actually going to store the vector representation of this question, which is our prompt, right? So now let me rerun the previous question, which is what's the capital of India, right? So I got a hit. The cache got hit, and I got the response. But now, instead of asking the same question, let me ask a semantically similar question, which is instead of asking what is the capital of India, I'm going to ask my question as what is the capital of the country that also has cities like Mumbai and Bangalore, right? So when we build generative AI applications, it's about our ability to ask semantically similar questions and then getting the same response, right? So again, if you see, I asked a different question, but with a similar answer, and this time also I got a hit from the cache, right? So this is where the vector search capability comes into picture. So we are not asking the same question. So it's not actually a keyword search, but it's a semantic search whereby any question with a similar meaning will result in a hit in the cache, and the response comes back, and we can kind of use the distance threshold to control the amount of responses that we want to get from the cache pack. Now, how is it going to be valuable in building a Gen AI application, right?
Yes.
So let's say I'm going to ask a question to OpenAI to write a short essay on the major scientific innovations of 20th century. Now, what I'm doing first here is I'm going to check in the cache that is there a similar question that's already stored in my cache? If so, return the response from cache. If my if the cache is empty, then I'm going to call my OpenAI and then generate the response from the LLM or the OpenAI, right? So let me quickly run this for us again. So now here, since the model is generating the response, it's going to take some time, right? So I have the response. It took 6 seconds for this response to be generated. Now, let me tweak the question, change it a bit. So I'm going to say, what were the major scientific innovations of the 20th century, right? I just slightly modified the question,
Yeah.
but because it's a semantic search that will happen on the cache, I would expect a hit. And the previous response took 6 seconds to be
Correct.
generated.
So that was a great topic today to understand something new, and what we can figure out is this brings in the concept of memory for generative AI applications, where you don't have to really hit the LLM every time to generate a response. If you have a semantically different version of the question, you can really hit the cache and get back the response. It is a game changer for building applications on generative AI because it definitely reduces your response time for applications. So thank you so much, Satish, for enlightening us on this topic. Great demo, and happy to have you here on TGIF.
Thank you again, Divya. Great to be here. Thank you.